Hi, this is Dr. Xu, teaching design of experiments for engineering research. If you are watching this video, congratulations on finishing my other videos in this course. We have been talking more on some statistic fundamentals. Further down the road, you will find it make more sense helping you understand the concept of design of experiment, and we will cover more topics on how to apply the basics to your experimental research. So stick with me for the other videos in the course. In this video, I will show you how to present the data from a single factor experiment, like using a box plot or a scatter plot, and performing the ANOVA analysis using the R code. We will use the same experimental results, so we have one factor, which is the chemical concentration at 5 levels. And each level, we have repeated 5 runs. So we have 5 observations in each level. In R, we can define a variable P15 to contain the 5 observations for 15% of chemical concentration. This sign is used to assign the value from the right side to the left side defined variable of P15. C is used to define a vector data type in R. I'll show you how it looks like in RStudio. I'll type in that line of code and enter. So I defined a variable P15 that contains a vector with 5 data. Now, if we type in P15 and enter, it displays the value of P15. And we can see that it is a vector with these numbers. These are the elements in the vector of P15. We can refer to the element in 15 by using, say, P15 square bracket 3. So this means I'm referring to the third value in this vector P15. So it should return a value of 15. Enter. See, the result is 15. If we put P15 square bracket 4, the returned value is 11, as 11 is the fourth element in P15. We can put the observations in other levels in the rest of the defined variables, P20, P25, P30, and P35. Next, we will put this data in a data frame. Data frame in R is like a table. I defined a variable strength and pass along a data frame, and in this data frame, the first column is the vector P15, and the rest of the columns are the observations for the other levels. If I type it in here and enter, if we display the strength by tapping the name of the variable strength, enter, we can see that the first column are the values in P15, and this column is this vector, and the rest of the columns are the same way. Also, now the vector name P15, P20, all the way to P35, they became the names of the columns in the data frame. We can also change the name of the columns by using this code. I changed the current name to 15, 20, 25, 30, and 35. I use names to change the names of the column. In the data strength, I use another vector with the concentration numbers. You have to put them in quotes to let the program know that they are characters instead of numbers. Now put the code in R and enter. If I display the variable strength and enter, now you can see the name of the columns become 15, 20, 25, 30, and 35. A lot of times we may store our data in an Excel file. We can also read it directly from R. Let me show you how to do it. Firstly, I will need to use this code to clear all the data that has been stored in the memory. Enter. Now you can see it says environment is empty. So there's no data has been defined or has a value. Next, install the readxl package by using this code. You just need to put in this script and hit enter. Wait until the installation process finishes. I will not do it since I have already installed it on my computer. Next, load the readxl package by using this code. I type it in here and enter. Before you can read data, make sure your current working directory is the same as where your Excel file is located. To see the current working directory, use this code, getwd. So I put it here, getwd, parentheses, enter. Here it shows my current working directory. I want to make sure it is the same as where my Excel file is stored. To set the working directory, we use this code, setwd, setwd, parentheses, quote, quote. For example, if my Excel file is stored here, I can click here and copy the path of this folder to here. Note that the copied path uses backward slashes here, here, and all the rest of them. But in our code, we have to use forward slashes. So I changed all the backward slashes to forward ones. After all backward slashes are changed to forward slashes, press enter. Now if I use getwd, it shows my current working directory is changed from this to this, and this is where I want it to be changed to. Lastly, we will use the read Excel command to pass the data in Excel to the variable we define here. If I open this Excel, as you can see, I have more than one sheet, and the data I want to read is stored in the third sheet. So I have the level of concentrations on the first row, and the observations are here. So this is going to be the name of my Excel file. I can either use the name of the sheet here to specify which sheet to read, or I can use the number of the sheet. In this case, it's the third sheet. So in R, I still define strength as the variable to store all my data. The Excel name is C32, and I want it to read the third sheet. Enter. Now if I display strength, you can see it looks like this, although it is slightly different than this, but basically they are the same. To plot a box plot, we use these three lines. The first and the last lines are the graphical parameters. You can just leave it as is. If I put these three lines in and enter, as you can see, the box plot is plotted here. These specify the data we're plotting. These specify the Y label name here, strength. This defines the minimum and maximum limit of the y-axis, so from 0 to 30. And this defines the X label name, chemical percentage shown here. To plot the scatter plot, we can use these scripts. This line calculates the means for each column in this strength data frame. We plot the strength data in the scatter plot, similar to the box plot. This is the data we're plotting. This is the shape of the dot. This is the Y label name, strength here, and Y-axis limit from 5 to 30. X label name is chemical percentage here. This line plot the means for each concentration using square and red dots. So this means a square dot and the color is red. In this line, I defined a legend to show that the square red dot is the group mean, so it is shown here. Lastly, we want to perform the ANOVA analysis. Before doing that, we need to convert the data into stacked type using this code. So I define new variable stacked strength by stacking the original strength data. Put it here and enter. If I display this stacked strength variable, enter. You can see it looks like this. It stacked the column together in the strength data frame, and it has the value, and it also has the concentration values. The first column, the default name is called values, and the second column, the default name is called int, which means independent variables. We use these two lines of code to perform ANOVA analysis and display the ANOVA table. This is the data we are analyzing. This is the name of the observations. In this defined data, the defined name is values, and this is the name of the independent variables. In it, the default name is IND. We put it here, enter. We can see a summary of the ANOVA table, the degree of freedom, the sum of squares, the mean squares, the calculated F value, and the P value. These three stars shows it's a very small value, less than 0.001. I have summarized the code here and posted below in the video description. You can copy them and paste it to here and work on it. Thank you very much for watching. Please leave a comment if you have any questions. If you feel this video is helpful, please subscribe, like, and share. This is Dr. Xu. I will see you in the next video.